Welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 12 from the practice paper for the 2025 Cambridge 0580 IGCSE non-calculator paper 2. Here we have a question dealing with vectors, and we have been given two vectors in column vector form P and Q, and we've got to do some vector arithmetic. We have to find the sum 2 times P plus Q. So we're going to take vector P and we're going to multiply it by 2. So 2 times 4, 6, and add to it the vector Q, which is minus 2, 7. So we can do this step by step to make sure we don't make silly mistakes. So 2 times 4 is 8. So this is going to be 8, and 2 times 6 is 12. Okay, so that becomes 8 and 12. Plus, you got minus 2, 7. So you have 8 plus minus 2, which is 8 minus 2, which is going to be 6, and you have 12 plus 7, which is going to give you 19. So 6, 19 is the sum 2p plus q. So multiply the first vector by 2 and then add q to that. Okay, so there's part 12a, part 1. Now a part 2 says find the exact value of, and it's given you this kind of notation. Now what it means is the magnitude of the vector P, means how long vector P is. So if we were to draw vector P, we would get a straight line which goes 4 to the right and 6 up. Something like this. Okay, this would be what vector P looks like if we were to draw it. It's just a rough sketch. So we go 4 to the right, and we go 6 up. So we're going to go 4 to the right and 6 up. It's a bit out of place there. Let me put it back here. Okay, good. All right. So this is 4 to the right and 6 up. So if you want to find the length of this line, which is the magnitude of the vector P, we can use Pythagoras' theorem. So it's going to be the square root of 6 squared plus 4 squared. Okay. Remember, we can't use a calculator for this, so we have to work this out in our head. So the square root of 36 plus 16, which is the square root of 52. Because we know that, the square root of 52. So now we have to give the answer as a surd in its simplest form. So we know that we're on the right kind of tracks. It's not a perfect square here. So when we want to write something as a surd in its simplest form, okay, so this is to do with surd form as well. We've got to think of a way of writing this number, splitting up into two parts. One of them is a perfect square, and the other one is, of course, going to be a number that's not a perfect square. So we think of two numbers that multiply to give us 52, and one of them is a perfect square. So we should be, in our minds, we should be thinking about the square numbers. We should be thinking of the numbers like 1 and 4 and 9 and 16 and 25 and 36, okay, and so on. Here we don't have to go too far because, we have to think about the square numbers, something times something that gives you 52. All right, so now, if we think about this, think about what one, if we multiply something by 1, you get 52. We don't have to worry about 1 because it's not really a proper square number in the sense that it won't help you to break anything down. But for example, 4. 4 times something gives me 52. 4 times 13, because 4 times 10 is 4, is 40, and 4 times 4 times 3 is 12. 40 plus 12 is 52. So you could even do a little division. 4 into 5 goes 1 time, remainder 1. 4 into 12 goes 3 times, 13. So 4 times 13 is 52. So that's one potential way of splitting this up. Can we think of a bigger number? 16 times something? No. Because 16 times 3 is going to be 48, so no. So it looks like it's just going to be 4 times 2, the only one that will help us. Okay, so we're going to write this as 4 times 13. This is the same as root 52, but now we have split it up into two parts. One is a perfect square and one is not. So the square root of 4 is 2. So we're left with 2 times the square root of 13. That's written as a surd in its simplest form. Okay, now for part B of the same question. Question number 12. Still about vectors, and it says here, A is a point 4, 1, and the vector from A to B is negative 3, 1. Find the coordinates of B. So basically, it's very simple, a question like this. You just have to add the x coordinate with the top number and the y coordinate with the bottom number. And the reason being is as follows, just so you can picture it. In case you don't understand why, I'll show you why. So supposing we just make a pair of axes just to make it clear. All right, just a little sketch. So it says a point A is 4, 1. So 4, 1, something like this. So this is 4, this is 1. Okay, this is the point A, 4, 1. And the vector A to B is negative 3, 1. So from A, you've got to go 3 spaces to the left and 1 space up to get to B. Okay, to get from A to B, you've got to go 3 spaces to the left and 1 space up. That takes you to B. Okay, that's the vector from A to B. So you can see here, you've got to do 4 plus minus 3. So you have 4, 1. You have to add negative 3. And you have to add 1. So 4 minus 3 is 1. And 1 plus 1 is 2. 3 to the left. That takes you to 1. And then 1 up. That takes you to 2. Okay, so those are the coordinates of the point B. All right, so hopefully you can see very clearly that's point A. To go from A to B, you go minus 3, 1, negative 3, 1. So you don't have to draw the diagram. That's just to illustrate it for those of you who maybe can't picture it. But basically, you know, you're going from A to B. So you have to add and take away. You've got to add minus 3 to 4 and add 1 to 1. If it said, for example, and the vector B to A is minus 3, 1, then you got to go backwards. Okay, then you got to, you know, if it's from B to A, okay, then you got to switch the vector around so that it becomes A to B, and then you can deal with it. All right, so there's the answer to question number 12, part B, and that concludes this question. And other questions from this particular paper can be found in the playlist that will be linked at the top of the screen. At the end of this video, other questions from the topic of vectors can be found in the playlist over here. And you can watch the vectors questions for my older pre-2025 playlist. You can see that from here. You can subscribe to my channel by clicking on the link on the top. Thank you for watching and see you soon.